fly through this real quick, but so basically the intro is a story about how I live on a boat and became friends with ducks, and then integrate them throughout my whole talk, and have kind of used them as my muses for different machine learning models, which I talk about here in this image recognition model that I was able to build recently, just as a piggyback onto an inception model. And so I'd want to really get across here, don't let this terminal scare you. I am not formally trained at all, and most of the time this is me, right? So I have no idea what I'm doing. Sorry, there's a seaplane. And that I literally just went to codelabsdevelopers.google and took one of these tutorials that's called TensorFlow for Poets. And this is an inception model that is trained on a couple of types of flowers. So it can tell you if it's a daisy, a sunflower, dandelion, etc. But once I saw how it worked, I thought, well, why can't I just add another folder to the model and train it off of some new images? So I wanted to add a folder for Linda the duck and Pumpkin, my pet snake. So I went to ImageNet, where I was able to download hundreds of duck photos. Actually wasn't able to download as many duck photos as I would have liked, but I downloaded, I think, around 1,000 ball python photos, which was pretty cool. And it turned out to do really well on both fronts. So super exciting. I might want to include that again too at the end here. So yeah, it did really well. And then imagine, applying this to SEO applications like image optimization. No one likes titling images or creating alt text. And for large scale websites, this would be absolutely huge. You could train a model on clothing fairly easily, have different types, and they could start to auto tag and auto generate some of that content for you. Machine learning is everywhere, right? This isn't new. We run into it every single day, and the applications are endless. Some of the really exciting ones to me are the medical related ones, where the imaging models is really starting to save lives through medical detection and etc. I love this quote. One of the major promises of AI is freeing people from mindless tasks so they can continue to do more meaningful work. That's exactly what I want to get across today, and to basically explain that this is accessible to every single person in the room, and it's going to help evolve the industry of SEO. So an example is, who in this room likes to create reports? Absolutely no one. They're the worst, right? And then I'm going to share this minute 40 video on NVIDIA and dashboard, I forget what it's called, that basically automates insights to your data. So you click on something specifically and it recalibrates the text on the side and points out insights you might otherwise completely have missed. So at this point, I hope to kind of have everyone's attention and be super excited. And this is just going to get better and better. So the format is, from here, I really just want to break down machine learning and then discuss other machine learning applications for SEO, and then go over some tools and resources to get started. So what is machine learning? It's a subset of AI that combines statistics and programming to give computers the ability to learn without explicitly being programmed. And it's not new, right? Machine learning has been around for a really, really long time and gone through ebbs and flows. One of the most interesting facts to me about machine learning is how it was inspired by a woman. Her name was Lady Ada Lovelace, and she inspired machine learning in 1843 during a party in England, where she basically criticized the analytical engine, which was a mechanically operated computer to do computations of math. And she basically said, this is currently making things available that we're already aware of. It's not producing anything new. And this sort of objection or, statement really stuck with Alan Turing, who later used it to inspire his work on the Turing machine, and he continued to refer to it decades later as Lady Lovelace's objection. I just love that. So there's two main types. There's supervised versus unsupervised. Supervised is what we've already sort of gone over with that image model. So supervised is when you're able to feed labeled training data. So these are all ducks within a folder called Linda, telling the model that this is what we want to associate with Linda. Something unsupervised would be more randomly generated data that wasn't necessarily properly labeled or categorized. Please let me know if that's an okay interpretation of that. I know, Jordan, you said something really interesting when I went over my talk the other day, and I couldn't quite remember how you said it, but I thought you said something really, really great about the supervised versus unsupervised. 3 common models. Oh yeah, and I think it was also about clustering. So if you wouldn't mind just sharing that again, that would be awesome. But essentially, I was having a hard time, how am I going to describe clustering, regression, classification? So with these 3 types of models, I don't want people to get overwhelmed and basically explain that this is statistics, right? It's basic statistics, and this is your unsupervised, is the clustering, and then regression, classification are more of your supervised models. So let's put some examples onto these. So crime locations, I didn't know what else to do for this one, to be honest. So if any of you have any other ideas, would love to hear them. This could easily be, home size versus selling price is a great linear regression. Classification is something like what we've already seen with the, is this a picture of a duck or a snake? That was added to that model. So I hope that helps kind of demystify these models. And then I go into what this looks like, right? So you have a bunch of training data, and you want to save a section of that data to later test the model on. But you basically train models on that data, and they produce models that you then test and outcome predictions or answers. So for example, we did this with the Linda pumpkin, the snake duck. And it was able to learn really, really quickly without us having to explain, okay, pumpkin is very long and skinny and has this unique head, where Linda has it just learns all of these things on its own as it iterates. But a lot of you are probably wondering, well, how do the models get smarter, right? How does that work? And it's actually quite simple. So when the model is training itself, it compares its results with the labels to determine a loss function. And the loss function basically tells you how far off the model is from perfect. So if these 2 dots were incorrectly positioned, that amount of incorrectness, now I'm just making up words, would basically be shown to help you gauge whether or not you need to continue training the data to better fit that line. But what you don't want to do is to overfit any model. So this is a common problem that looks like this, where you try to basically make every single training answer correct, right? You want to figure out every single thing, but these sort of lines and overfitting don't do well for newly added data to come. So you really want softer lines that help allocate or, take into account future data. So the best way to explain overfitting would be, having a bed like this. It doesn't account for future sleeping patterns, I hope that helps explain it a little bit better than my gibberish. So if machine learning was a car, data would be the fuel. So data really powers these models, and it's all about having clean, properly labeled data. And that's why we were starting to see more and more of this, right? Google and websites everywhere are sort of having us label some of the data. It's super interesting. We see it on Google Photos, where Google will suggest a popular category of images, In this case, it's sky, mountains, selfies, there's all sorts of others. And then it runs through a series of pictures and just asks you, does this image contain mountains? And you say yes or no. The really powerful aspect of machine learning is that it's multidimensional, right? This isn't just a flat type thing. You're able to take in potentially hundreds, if not thousands, of different features and create predictions from patterns you could never otherwise do manually or at a glance. So this basically kicks things like Power BI's butt. It's like Power BI on steroids. So this is part where I apologize to Will. So how can we apply it to SEO? So I hope you guys like these additions. I'm super excited about these. So for large websites, it's really hard to optimize and manage all of the pages and their meta descriptions and their title tags, right? So for example, a site like Moz has these community forums where the meta descriptions aren't great, right? That's not super helpful if someone's searching about this. So in comes models like Summarizer on Algorithmia, which is a model I found, which is basically summarizes long form content. So I thought, well, I'm just going to give this a try. So I go to that page, this Q&A page that I found here, and I basically take all this text from the question and the most upvoted answer. I put it into the model and it output this. I then cut that down to fit the size of 160 characters for a meta description, and you can tell that it actually does way better than what's currently showing for our meta description for that page. So just imagine if you could automate this for thinner content pages like that. That would be, take weeks, if not months, for an individual to do on their own. And of course, it's not going to be perfect, but having something there other than, nothing would be good. So can you believe that? Isn't that amazing? Super exciting. I hope this gets people fired up about, starting to take over some of the more banal aspects of SEO work. Recommendation models are evolving and getting better and better and better. We see them all the time on websites, right? And last year, I got to speak about how our recommendation model on the blog was a little bit wonky because it was pulling from all three of the categories of a particular post, and it wasn't pulling very good suggestions. So I kind of fought to get it to pull just from the main category, and the results immediately improved. It was super exciting, and then we saw pages per session went up a little over 11% year over year. I believe it was a little over 4.6% the previous period. So this is going to evolve and become even better, right? Imagine if we can pull models like this one I found on Algorithmia that recommends pages based on its content and other pages that you have on your site and pairs it with user data, right? Has someone read that article before? What kind of content did they browse last time? This is going to start to get really, really customized and really, really great for users. It's going to help visitors stick around and get more value out of your website, which is super exciting. Voice search opportunities are huge. Something that's really fun to play around with is Google Actions. So this idea that you can create an action for anyone with access to a Google Home device or Google Voice. It already comes with 3 built-in templates. So there's a trivia template, there's flashcards, and then there's a personality quiz that just come right out of the box. You don't have to program anything. If you do want to do a little bit of customization to your action, you will be kind of pushed over to Dialogflow, which isn't as intimidating as you might think, and has really interesting small talk information that Google would like you to have answers for in case users start engaging with your application. And what's so exciting here is this is basically the first glance we as SEOs have at keyword research for voice. These are some of the most commonly asked small talk questions that people are asking their Google Homes, and it's pretty hilarious. There's some really funny things in there. So I went ahead and started building this SEO quiz back in December, January, and had a lot of problems getting it published, primarily around the way that Google was interpreting phonetically Moz. So the invocation name was, Moz SEO quiz, and it was being picked up as Ma, like mom, and it wasn't working. But I actually decided just to strip out Moz and keep it simple and SEO quiz, and it got published. So super exciting. If you want to play around with it, you just have to say, hey Google, talk to SEO quiz, and it'll start asking you questions, which is fun. I don't know if I want to include this. I think it's super powerful, but I don't know how many people will follow. But basically this section is just going over, parsing McParseBase is the most powerful open source technology to understand language. It's unbelievable what it can do. And it's super easy to actually use. So back when it was released, I remember feeling super intimidated and never thinking that I would be able to play around with something like that. And now I just log into Colab and use Algorithmia, and I'm able to play around with it all the time. So this was something I was playing around with a while ago, and I wrote this. My hope today is to plant a seed of machine learning within each and every one of you. You hold the power to create the next cutting-edge machine learning applications. And it basically parses out this text as to what each individual word means. And if you think of the applications for this, it's endless, right? Chatbots to the next level, emails. You can start doing all sorts of really cool machine learning programs around user messaging and text. Other SEO opportunities for machine learning, right? These are some of the things that were top of mind, but honestly, the opportunities are endless as far as applications and integrating it into different uses for analytics and prediction. So super, super exciting. And I think people in the audience will have even better ideas than this. But tools and resources. So how do you build your first ML model? The most of your effort will be around cleaning and collecting a data set. It really is most of the work. I know when I play around with some of these things, I'm always just doing dumb struggling around stuff with images, or silly stuff. But building the model is relatively super, super easy. There's all sorts of resources to help you. Training is one line of code, evaluating is one line, predicting is one line. So it has come a really, really long way. And you don't have to be intimidated because there are things like code labs that really help you walk through from start to finish. There's also a really great introduction to machine learning crash course that Google has. It walks you through all the different aspects of machine learning. TensorFlow has really great resources on how to get started, and you can learn about eager execution, which is sort of like the hot new thing of TensorFlow, and they've got great tutorials there as well. Colab is one of my new favorite shiny toys because it allows for free GPU, so it's a lot faster than some of the Jupyter notebooks, and you don't have to know hardly any code to get started. So Jupyter notebooks, it's basically the same thing on your local computer, but you do have to still download and import different libraries and programs to get started. Here, this comes complete with Python, TensorFlow. It easily integrates all sorts of other libraries so that you're not taking that space up on your computer. And it also comes, right out of the box with some really cool matplotlib, graphs, interactive charts, you name it. The things you can do in this is is incredible. And it's fun because it really is collaborative. So you can work on models collaboratively and sort of have a more easily accessible home base for some of these things. I don't think I'll go into, I play with this stuff all the time, but is this funny? I figured out how to analyze Twitter accounts for just like sentiment analysis. But this top area is basically what Rand has recently been negative about. And then this area is what Rand has recently been positive about. I just think it's so cute that Casey Henry and Will Reynolds are in there. I just thought that was so funny. That might have to go on bonus slides or something, but yeah, I don't know. I'm able to do all this stuff within Colab and just using Algorithmia. So it has a built-in image recognition model that's not super great. I mean, this is also kind of a hard picture to train on it. I would just wanted to compare my model with their model, which isn't really fair, but it basically pulled up the blanket for most of the subject. I'm excited to make everyone aware of Kaggle, and also if any of you have any suggestions on how to say this so not everyone in the audience thinks I'm saying Kegel, that would be awesome, because every time I've talked about this at conferences, I get the weirdest looks. Like, oh, no, that's a name. But I try to say Kegel with a hard A. I don't know. Anyways, it's funny. There's this, author identification. So this is obviously like the largest data science competition website, where there's constantly new competitions that are put up, and companies put money and then teams compete. Spooky author identification. The TSA one's really kind of creepy, and the fact that they put up $1.5 million is insane. And really, I would love to have time to go into the bias of data and ethics of machine learning, but that's an entirely different talk, right? So the models are only as good as the data, and as humans, we are biased. There are, going to be racially driven data sets, and we need to be so careful, and it needs to be something that's talked about a lot more. SEOs are going to love this because we love Quora, but Quora is trying to figure out how to get rid of their duplicate questions. Google is trying to figure out how to understand their never-ending, incoming YouTube videos, and how to properly label and tag different things. I would love to talk about the Netflix challenge if time allows, but I sort of doubt I have time. I don't know. How am I doing on this? Does it show me? I don't know. I just think that's a cool story. Briefly touch on the evolution of how hardware is quickly improving and following Moore's law pretty closely. So, we went from CPU to GPU, and now Google has released TPU for TensorFlow models that has just quickly accelerated the rate at which you can run some of these models. And then I just came up with the sort of beginners getting started resources, and then advanced resources where people can dive a little bit deeper. And then to recap, okay, what did we learn? Machine learning combines statistics and programming. A model is only as good as its training data. The loss function helps us improve the models, but overfitting should be avoided. And that everyone in the room can create a machine learning model today. They really, really can. Machine learning will help scale SEO tasks and allow us to evolve as SEOs, which is super, super exciting. So, I hope everyone is leaving today thinking about what are they going to create with machine learning, or what kind of models might they put together. And then I revealed that my wild pet duck Linda did have her babies. 3 of them hatched, and I completely lost my mind. I ugly cried all day. This is what I usually look like. I just thought those pictures were so hilarious. And these are the ducklings, and they're so cute. It's funny, they actually die most frequently because they can't get out of the water in the marina to rest, so we built them this duck ramp, and they used it all the time. So all 3 are still alive and well. But yeah, I hope everyone enjoyed the talk. Thank you so much. I've got a bunch of slides down here that I did not include but think are kind of cool. But yeah, really excited to hear your feedback and thoughts on how I've sort of reorganized this. I cannot thank all of you enough. I owe you guys big time. Thank you so much for watching this and helping me out. Sorry for the noise. Okay. Have a good weekend, and I'll talk to you guys soon.